But before I get started, thank you, Dan and Cheryl, for kicking off the keynotes today. So what we wanted to do was have themes for the keynotes, and as we organized the keynotes, we didn't organize them with themes, but we were able to come up with some things. So this morning's session is about the pervasiveness, the far-reachingness of Kubernetes. As Dan informed us earlier, there's a lot of different ideas out there from a lot of different places. And as Cheryl said, she put out some numbers. There's a lot of code being slung around. And in a second, I'm going to go over some project updates with some friends from the community. And then we're going to hear from some contributors. And really what I want to say is that really Kubernetes has creeped into every single crack and nanny in this ecosystem. So before I go into the project updates, there are a few folks we need to thank, because without them, none of this would have been possible. So first up, let's thank the Diamond sponsors. We have Cisco, IBM Cloud, Microsoft, Azure, Oracle, Red Hat, and VMware. Thank them. We also have Platinum sponsors. Thank them. And our Gold sponsors. And most importantly, we have our Diversity Scholarship sponsors who helped, wait. They helped fund 56 full scholarships with $100,000. Now, thank them. It says, all right, so be sure to visit with all of our sponsors in the sponsor showcase while you're here, and make sure that you thank them for helping us put on, this really amazing event. And real quick, I'm going to go off script. I know they hate this, but I met 2 of the Diversity Scholarship sponsors over the last 2 days. You know what? You thought you had ideas? These folks flew halfway around the world, and they have crazy ideas. All they need now is access to some of this great stuff that we provide here. So just keep that in mind. So now, last but certainly not least, if you are one of the 107 members of the program community for Barcelona, please stand up. These people, they volunteered their time over 1,500 proposals for this year's event. Now, let's give these folks a round of applause. And I want to give a special shout out to all of you all, because I know when we went through these presentations, the reviews, the quality of the review comments that came through was super helpful. You all submitted an awful lot of talks, and without the committee, there is no way we would have been able to get through them. So now I'm going to move on to the project update. So every year we do this. What we're going to do is we're going to give an update for a few of the CNCF projects. But first, I want to set the stage, because one thing that I didn't have was context about how CNCF projects work. So there's this quote, and it's funny that Dan actually mentioned this in his talk, but I'm going to read a part of it. It says here that cloud-native technologies empower organizations to build and run scalable applications in modern dynamic environments, such as the public and private clouds. And then containers and service meshes and microservices and mutable infrastructure and declarative APIs exemplify this approach. So what we have in all the CNCF projects are projects that just help further this mission. And I like to show this right here. This is the crossing the chasm chart, or the chasm, I'm sorry, I'm not good at this. Is the crossing the chasm. And really what we're doing is we're trying to show where these projects fit. So you'll notice starting from the left, we have the innovators, and then we have the early adopters, and then we have the early majority. And this is what we're focusing on. And what we're looking at here is how do we help set up projects from the beginning and grow them into mature projects. So right now, there is 16 plus 16 plus 6, so that's 32 plus 6. There's 38 projects that CNCF is sponsoring right now. And what we're going to do is go over a few of them, starting with staging. First up is OpenEBS. And what OpenEBS is it enables container-attached storage using Kubernetes itself as a substrate for storage management. Now, I was not familiar with this project, but as I dug into it more, it's actually pretty interesting. So really what it does is it provides multiple functions. Your storage can live in a container, or OpenEBS can provide a common layer that allows for developers to have a single experience for exposing storage. And so here are the updates. So with the latest update, we have container-attached storage now, and we actually have a lot of fixes for additions to the data engines. So there's the Jiva, and then there's the CStore, and then there's also this OpenEBS extension of local PVs. So moving on, let's go to Incubating, and we have a few projects we want to talk about in Incubating. The first one is Linkerd. And Linkerd is a lightweight service mesh that enhances your application's observability, reliability, and security without code changes. Now, I could do and say a whole bunch of things about Linkerd, but I went one better. So what I'd like to do is invite Oliver Gould up on the stage from Buoyant so he can actually tell you the updates for this project. All right, man, here you go.
Hola, ¿qué tal? Hello, what's up? How's it going? My name's Oliver Gould. I'm the CTO at Buoyant and creator of Linkerd. The last 9 months or so since we launched Linkerd 2, I think September of last year, has been an incredible ride. The project has never been at a faster pace. We've had 33 edge releases since then, 5 stable releases, and we'll have a 6th stable release once we all recover from KubeCon. There's been a whole bunch going on. Because we're focused on being lightweight, we've asked the folks at Kinvoke to help us develop a service mesh benchmark framework so we can understand the actual cost of operating a service mesh. They posted a blog post, I think, on Monday. It is wild. I really encourage you to check it out. We also have some exciting things coming up in the next release. I'm not going to really talk about that here today. I heard there may be some crazy demos at a keynote this afternoon, though, so check that out. And of course, I have to tell you, we have a booth in the vendor hall. If you see anyone wearing a Linkerd logo and you have questions, that's what we're here for. Come ask us. But before I get off the stage, I want to try to do a little demo of my favorite new Linkerd feature, automatic MTLS for service identity. And so when you deploy microservices, especially in Kubernetes, but anywhere, they tend to share lots of data over the network. That means anyone sitting on the network, sitting on a node, anyone with netadmin in Kubernetes can actually just sniff this traffic. And so here we see just sniffing some TCP dump traffic. We get usernames, ages, dates, social security numbers, whatever. And that's just really not an acceptable default, in our opinion. And so we set out in Linkerd 2.3 to make this happen by default. And so now proxies provision their own identity without configuration when they start up. And when proxies communicate with each other, they validate identity, do encryption, and everything's good to go. So now when we go try to tap into our TCP stream here, what we're going to find is that we see nothing. We see only health checks and, of course, a bunch of opaque TCP traffic. Again, this is all part of Linkerd's philosophy of being lightweight, providing zero config solutions so that you don't have to change your code to get this benefit. If that's interesting to you, come talk to us, come find me, come find anyone with the Linkerd logo. I hope you have a great conference. Thanks, everybody.
All right. So next up is Helm. You know they sat right up front just before that. So Helm is the Kubernetes package manager. Who here has not heard of Helm? All right. Well, we do have some exciting updates straight from the Helm team here. So what is Helm? Because they provided these slides, and I want to do them justice. Helm is client-side only. what it does, it pushes the charts. So this is with Helm 3 now. Pushes the charts in OCI registries. It validates chart configuration with JSON schema. Release names are scoped to namespace. This is a big deal because now in production, you won't have elephant-dog as a release name because no, you don't want that. You call it what it is. My next startup idea. But also, you can declare dependencies in chart YAML instead of requirements YAML, one less file. And there's a lot more in the release notes. I swear the update I got from this was like 50 slides, and I'm like, I can't do all this, so I'm going to distill it down. But here's the big announcement, though, is that Helm 3 is finally coming. There's an alpha release now, and it's on the release site. But the big thing about this is that there's a tiller has been removed. They have listened. The tiller is gone. And more importantly, now you can validate your chart values. That's a very big deal. And the neat thing is now that we don't have to concoct all these mechanisms to actually share our charts. Helm 3 actually will support library charts. So more information about Helm 3. There's the GitHub release notes on the release. So go to v3.helm.sh. And then there's also a blog post at helm.blog or /blog. So another announcement for Helm. The Helm Summit is happening this year on September 11th through 12th in Amsterdam. And the CFPs are open. Deadline is end of this month. I went to the first Helm Summit. It's a good event. I swear there's a lot of smart people in the Helm community that get together to share all this information. You'd be very surprised at the quality of talks and the quality of information shared there. So, Helm Talks. Well, today we have a Helm 101. And then there's also, on Thursday, there's a Helm deep dive. If you're really interested in Helm, this is where you should be. Next up is Harbor. Now, Harbor is an open source cloud native registry that enables organizations to enforce policy and compliance for container images. Now, today, I believe VMware is announcing that Harbor 1.8 has been released. And I swear there is a lot of changes in Helm 1.8. I was not going to put the whole blog post in slides, so I will do you a favor and summarize them for you really quick. So really what we have now is support for OpenID Connect. This is more ways to authenticate people to connect to your Helm. There's also support for robot accounts. Now you can actually have GitHub accounts you can use a GitHub robot account to actually work with Harbor. And then there's also enhancements for replication. Now there's also more features. The Helm team has been the Harbor team has been really, really busy. And so there's the health check API. And then there's also an update to the Docker registry to make sure that they are compliant with the latest version from Docker. And then there's also support for scheduled tasks. Next up is Rook. Rook is production-ready block and file storage. So Rook recently has released Rook 1.0. And once again, I will say that there was a very long blog post about this, but I read it for you and took out the highlights. The big features are there in the Ceph, the edge FS, and the Minio operators. There's big updates for all of them, especially for Ceph. Ceph, I think it moved up to the current version of Ceph, and then Minio and edge FS operators are operated as well. But take a look at the edge FS. There's actually support for backups now, so you can actually back up these things. It's actually made for that. And then there's CSI support, and then also this blog post here at the end. So next up is Cryo from Red Hat. Cryo is an implementation of the Kubernetes CRI to enable the use of OCI-compatible runtimes. And before I bring up Arvashi, I want to say that that is a mouthful. So really what it is saying that because Kubernetes is a platform for platforms, all the things for all the people, we're not stuck with just having containerd. We can actually replace the runtime. And Cryo is a good example of that. So next up, I'm going to introduce Urvashi Monani, and she's going to talk about Cryo.
Thank you, Brian. And hello, Barcelona. Wow, this is amazing. I'm super excited to be here to talk to you all about Cryo today. This is my first keynote, by the way, so yeah. So what is Cryo? Cryo is a lightweight container engine designed for making Kubernetes container deployments as seamless and secure as possible. As Brian mentioned, Cryo implements the Kubernetes Container Runtime Interface, hence the CRI in Cryo. The O stands for Open Container Initiative, which means that Cryo supports all OCI-compatible images and all OCI-compatible runtimes, such as runc, kata, gvisor. Yeah, we were really creative with the name, weren't we? So, Cryo was built to embody Unix philosophy, which states that you should design programs to do one thing, to do it well, and to work well together. To that end, Cryo uses a number of libraries under the hood that focus on different areas of the container space, such as storage, image management, and networking. This way, the building blocks of Cryo can evolve at their own rate, while Cryo picks features that fulfills Kubernetes needs. So now, Cryo is not built to solve all the problems out there in the container space. It's a huge area, right? Cryo's main focus is to run containers securely and seamlessly in production environments. We have other products such as Builder, Podman, and Scopio, which use the same libraries to solve adjacent problems in the container space. Cryo loves Kubernetes. Kubernetes is Cryo's one true love. What this means is that Cryo does not cater to any other container orchestration tools out there. Cryo tailors itself to meet the needs of Kubernetes only. Nothing more, nothing less. All the PRs submitted to Cryo must, in addition to passing Cryo's integration test suite, also pass the entirety of the Kubernetes end-to-end test suite, ensuring that we are always, always compatible with Kubernetes. Now, to further Cryo's devotion to Kubernetes, Cryo's release cycle walks in lockstep to that of Kubernetes, meaning matching versions of Cryo and Kubernetes are guaranteed to always work together. And users don't have to have a chart to keep track of what version of Cryo works with what version of Kubernetes. If you're Kube 113, Cryo 113 is for you. So all this ties into Cryo's main purpose, which is to make running containers in production as boring and secure as possible. Now, let's take a look at Cryo's journey so far. So in early 2016, there was a proposal to create a simpler and more secure OCI-compatible container engine just for Kubernetes. And voila, a few months later in September 2016, Cryo was born. About a year later, in October 2017, Cryo 1.0 was released. And since then, we have got multiple versions of Cryo, with version 1.14 being our most recent stable version. And finally, the best news, we joined CNCF last month as an incubation project, and we're all super pumped to finally be here. So as of now, Cryo is running in production at Red Hat, SUSE, and Lyft. Cryo is going to be the only supported container engine in OpenShift 4.1 and above. And Cryo has integration with tools such as Sysdig, Aquasec, NVIDIA, just to name a few. We have over 100 contributors, and Red Hat, Lyft, SUSE, Intel, and IBM are main contributors and users so far. Now, I'm sure I have somewhat intrigued you guys to dig more into Cryo. And if you all can't wait to get started, here are the links to our GitHub page and our website. We're available on IRC and Slack. And don't forget to stop by the Red Hat booth for some technical demos on Cryo and friends, as well as to chat with us and get some cool swag. So I would like to end by giving a quick shout out to our Cryo contributors and maintainers out there for their amazing effort. Thank you, and have a great KubeCon, everyone.
All right, so That was actually pretty good for Aveshi. Give her another round of applause on that one. So next up is open census and open tracing. I've actually used both of these. And as I was sitting down to write the updates for these, I realized that, you know what, I can do better than that. So instead of me actually talking about their updates, I brought someone from Open Census and someone from Open Tracing here to talk about what's new in their world. So let's welcome to the stage Ben Siegelman from Lightstep and Morgan McLean from Google. They have some pretty cool stuff to share today.
Hi, everyone. For the record, I'm Ben. This is Morgan. Thanks a lot for coming to this wonderful conference. So let's talk about your application and how different people see it. So your end users see something very small and elegant. It's just this little white iceberg that they use and derive tremendous business value from, I'm sure. Let's talk about how someone else sees it. This is how your CFO sees your application. It's probably more accurate. It's big. It's got a lot of stuff. It's real expensive. Things are breaking. They probably don't understand what, but they know that there's a bunch of shipwrecks at the bottom and that they're getting charged for those too. So your CFO is not very happy about it, but so be it. And then you have the developers. The developers understand, no, this is not a monolithic iceberg. This is actually a microservice iceberg. There's lots of little pieces. They're all talking to each other. I don't really get it, but like, there are lots of services. I would argue that none of these people, the end user, your CFO, or at least your devs, if this is their view, actually have any idea what's going on. That's my contention. What's actually happening? That's the big question. What's actually happening? The answer has to do with observability. This is a very trendy word. It's not a new word. It was coined in the 1960s in the control theory discipline. It's basically, observability is a measure of how well you can understand a system given only the telemetry data that escapes. So this is really important to understand. Your ability to observe your system cannot be any better than the data that's coming out. If you have to redeploy your software in order to see it, you're already losing. So the telemetry is, it's the essence of any observability strategy. Not the entirety, but the essence of it. So if telemetry is so important, it must become a built-in feature for cloud-native software. It must. And this is what typically in our world that we inhabit is distributed traces, metrics, logs, that sort of thing. And it's necessary for us to find some way to amortize the cost of getting high-quality telemetry. It is not reasonable for every developer to hand instrument every service. We need to somehow manage to move that effort into the open source and do it once for everyone who depends on cloud-native software.
And so this is a good pitch, right? So anyone who's worked in this space is probably pretty aware that telemetry is important, and they're also really aware that getting it out of your application is incredibly difficult. The problem with this pitch is you've heard it before, both from open tracing and from open census. Now, intuitively, you might not think that this is a problem. Hey, there's two successful projects here. They're both growing quickly. They both achieved some amount of escape velocity. This is a challenge, though, for anyone who maintains things like shared code. So shared libraries, web frameworks that you might use, they now have two different interfaces that they need to bind against if they want to export traces, metrics, or other types of telemetry. This is also a problem for service developers who often want a single implementation to work against. So we've heard all the challenges that people are having in this space, and we're really excited to just talk about OpenTelemetry. OpenTelemetry is what we're merging open tracing and open census into, both the projects and the communities themselves. It's effectively the next major version of both open tracing and open census. It's what people will migrate to. OpenTelemetry offers the best parts of open tracing and open census merged together. We have a single set of APIs and implementations across all languages that you can bind against and that you can use to capture and export telemetry from your applications. And we also offer agents and a number of other shared components. OpenTelemetry is going to be backwards compatible with both open census and open tracing via software bridges. You certainly should bind against the new APIs once they're available, but if you have existing code or existing integrations, you can use those bridges to use the newest implementation with your existing code without changing it.
Yeah, so we only have a few minutes up here today. Because it's a new project, it's very important for us to actually talk with end users, get your feedback, and share more details. So we're hosting 2 separate workshops today. One is just a panel discussion, which is basically to say that a bunch of folks from OpenTelemetry, which is Open Census and Open Tracing, will be there to answer questions about the project, how we're maintaining backwards compatibility, et cetera. Backwards compatibility is such an important thing that we have a special session just about that. You can see the times on this slide, and we would welcome all of you to attend either or both of these.
Yeah, so thank you very much. The room for both of our panels is just down the hall in CC7, so we hope to see a lot of you at 11:05. Have a great conference. Thanks for listening to us. See you.
All right. So we're going to conclude this session with something that's pretty important. It's the fact that there's actually a process that CNCF projects run through. So we talked about a staging project. We talked about a couple of projects in our incubator. But now, what we're really trying to do is move projects to this graduated state. And really what that is that is the project an early, does it have an early fast mover? Is it really the early majority? Has it captured the mind share? Does it have all the things? Does it have proper governance? Is it just a proper project? So right now, we're up to 6 graduated projects. The first graduated project was Kubernetes, it was. But now, we're up to 6. So the 6th project is FluentD, and they just graduated. And because I like this theme of me not talking about other people's software, what I'm going to do is I'm going to invite Eduardo Silva up from ARM up here to talk about FluentD. So Eduardo? All right.
Thanks. Buenos días. How are you doing? Fine? Good. That's good. First day. So my name is Eduardo Silva. I'm a principal engineer at ARM. And today, before talking about FluentD itself, we're going to talk about logging. And logging itself exists because we want to solve all the data analysis problem. You cannot do data analysis if you don't have the data, right? We have databases, but data is a fundamental piece for that. But there are many challenges in order to solve logging. And one of them is that application is distributed. And also, the logs are now streams of data. They are not longer just a few bytes in the file system. It's not longer that. But also, all the developers that we are here generate our own applications with data in their own formats, which makes things crazy. So how do we achieve this data analysis? To solve this problem, we come up with a design years ago about, OK, if we want to collect data and we want to ship the data out, this needs to be like a black box. But inside, we need to collect the data from an input. We need to parse the data, filter the data, and do some buffering because you don't want to lose your data, and then ship your data out through routing to any kind of database or cloud service. And that's what FluentD really is, a full solution to implement a unified logging layer. FluentD has its origins on 2011 at Treasure Data Company, which is now part of ARM. And at that moment, if you have a company that is going to sell a service to process data, you need to collect the data. But the huge win here is that it's not about what we did as a company to solve our problem, because also when we created FluentD, FluentD was created in open source. And happened that at the same time, many people have the same problem. They have a bunch of data for different formats, different streams, and they didn't know how to collect this data. After that, we went to a huge adoption of this because of open source. And it's not after, well, a few years after that, 2015, one person from our team implemented the native Docker logging driver, which means on that moment the ability to take your Docker container and ship the logs straight away over the network to FluentD, skipping the file system or any kind of storage persistency on that moment. 1 year after that, we joined it as CNCF in 2016 as an incubation project. And then 1 year after that, we reached 1.0. But it was not until now, until April of this year, that FluentD has officially graduated. It took us 2 years, but well, I would like to get some applause for the team that really worked really hard on this. And how about one project graduated? It's not about to get a tag or a label, hey, we are graduated. It's more than that. It's a responsibility, because we have a huge adoption. Most of cloud providers are using FluentD. Most of companies that had login problems, they use FluentD. And I'm talking about Microsoft, Google, Red Hat, VMware, Pivotal. So, and in general statistic, you can see that now we have, in general, almost 200 releases. The community has built 1,000 of plugins. That's what was, I would say, that the second key of success of FluentD. It was not just to ship data to just one database. Let the community decide what to build, to which integrate, which kind of filters. And nowadays, it's 1,000. We have 8,000 GitHub stars, and we hope to reach 200 contributors this year. And one of the channels to distribute FluentD is Docker Hub. If you are deploying on Kubernetes or any cloud native solution, you're using Docker Hub, and now we reach 100 million downloads of Docker Hub pools. And talking about to the FluentD maintainer, who's Masahiro Nakagawa, he's here with you this time. I asked him, what do you think about this FluentD become graduating, FluentD becomes widely adopted? And he said, well, it's not a surprise, because the product was made in order to scale, in order to solve a problem, and with different challenges, not just for the cloud-native environment, but also for the standalone application. And that's why it has succeeded. And now, just a few technical updates of FluentD. Today, we are reaching FluentD 1.5. And there's one point in a software that you need to stop implementing new features, but you need to start focusing on more stability, better integration, and performance. And I would say that FluentD 1.5 is about performance and more security. Everything can be more performant, and everything can be more secure. And that's what is FluentD 1.5. In the forward protocol, to send data from one FluentD to another, we implemented a full keep alive feature that was not there before, but it implements and allows you to ship data faster and optimize the bandwidth. Also, we implemented more security in some output plugins, and we improved the support to have more scalability on environments where we have multiple CPU cores. And in community update 2, FluentD is now part of Docker Hub library. So you can do Docker run FluentD, and you will get the latest version officially. And this is not maybe too fancy, but what is fancy is that we have support for ARM architecture, ARM64 and ARM32. So in a community, one thing, the most important thing is the community. And I will say that the second one is documentation. So the team put a lot of effort on write a new documentation website for you, because if we look at the stats of the project, actually it's not about how many people hit FluentD website. It's about how many hits do we really get in the documentation side. And thinking about how do we improve testing, how do I CI, for example, who has created a pull request here? Raise your hand. Half of you. OK. Pull request is a contribution. When that contribution hits an open source project, that project needs to run a couple of tests over your contribution, because we don't want to have bugs, we don't want to have regressions. So how do we improve that? So FluentD team has partnered officially with GitLab company, and GitLab has offered a full new CI/CD service for us, where they have migrated our old system to the new ones, and now we can say that we speed up our development and testing in a 200%. So what's new also from a community perspective? If you want to learn more about FluentD, we have a new training course has been created by Linux Foundation and RxM. You can learn how FluentD works, how to configure it, how to take the best practices for cloud-native environments, and it's already available. And it's not just about FluentD. FluentD, I always say, that is a huge ecosystem. We have SDKs, languages, and so on. FluentBit, which is a sub-project of FluentD, it's getting into edge computing too. It solves logging problems. But now we are getting with stream processing capabilities. If you know what stream processing is, it's basically the ability to perform data processing while the data is in memory, is in motion. And we are investing a lot of effort, engineering effort on that area. So if you want to know more about FluentD, FluentBit, the whole team is here in the conference. So today we have a talk about 2 p.m. about FluentD, introduction, updates. Tomorrow about FluentBit. We have another third-party talks about FluentBit, and the FluentD team will be in the CNCF answer bar, in the maintenance track, so you're welcome to join us. Thank you so much.
Thank you. All right. So that brings us to the end of our CNCF project updates. I just want to leave that with, there's a lot of people out there doing a lot of hard work writing this software and giving it to us. You know, it's a lot of blood, sweat, and tears. I didn't mention, notice I said there was 16 plus 16 plus 6 projects. I believe that's 38. We didn't mention that many projects, but there's definitely work going on out there. So I just want to give a final round of applause to all the CNCF projects for all the hard work that's going on